Black box testing is a software testing method. It examines the software's functionality. It does this without peering into its internal structures or workings. Testers interact with the software as a user would. They provide input and observe the output. This helps determine if the software behaves as expected. Imagine a car. A black box tester is like a driver. The driver focuses on how the car drives, steers, and brakes. They don't need to know about the engine, transmission, or other internal parts. Black box testing is essential in software development. It helps ensure that the software meets user requirements. It also helps identify defects and errors that might not be apparent through other testing methods. By focusing on the user experience, black box testing can uncover issues that might be missed when only looking at the code. This method is particularly useful for validating the end-to-end functionality of the software. It ensures that the software works across various platforms and devices. Ultimately, black box testing contributes to delivering a reliable and user-friendly product. Testers document their findings meticulously, providing valuable feedback to developers. This feedback loop is crucial for continuous improvement and quality assurance. As the software evolves, black box testing remains a key component in the development lifecycle. It fosters collaboration between testers and developers, ensuring that the final product meets the highest standards. In the end, black box testing helps create software that users can trust and enjoy. In black box testing, the focus is on what the software does. How it does it is less important. Testers design test cases based on the software's specifications and requirements. They input data and observe the output. Any deviation from the expected output is considered a defect. Black box testing is crucial for several reasons. It simulates how users will interact with the software. This helps identify usability issues and ensure a positive user experience. It uncovers errors and defects that might be missed by other testing methods. It verifies that the software meets the specified requirements and functions as intended. Black box testing can be performed by a separate team. This provides an unbiased assessment of the software's quality. Black box testing encompasses various types. This type focuses on the software's functions. It checks if each function operates according to the requirements. This type goes beyond functionality. It examines aspects like performance, security, usability, and reliability. At Section 5, Functional Testing, ensuring the software does what it should. Functional testing is like testing the buttons on a remote control. Each button should perform its designated function correctly. For instance, login functionality. Verify that users can log in with valid credentials and are denied access with invalid ones. Search functionality. Test that the search bar returns relevant results based on the entered keywords. Order placement. Ensure that users can add items to their cart and successfully complete an order. Section 6. Non-functional testing. Looking beyond the basics, non-functional testing is crucial for a well-rounded assessment. Performance testing. Evaluate how the software performs under different loads, like a high volume of users or large data processing. Security testing. Identify vulnerabilities and weaknesses that could be exploited by malicious actors. Usability testing. Assess how user-friendly the software is and identify any areas that are confusing or difficult to navigate. Reliability testing. Determine the software's stability and its ability to function consistently over time. Section 7. Techniques for effective black box testing. Several techniques aid in conducting effective black box testing. Equivalence partitioning. Divide the input data into groups or partitions. Each partition should produce similar results, reducing the number of test cases. Boundary value analysis. Focus on the boundaries or edges of input values, as defects are more likely to occur at these points. Section 8. Equivalence partitioning, dividing and conquering. Imagine testing an age input field that accepts values from 18 to 65. Instead of testing every single number, equivalence partitioning allows you to create groups. Ages 18 to 65, for example, test with 25, 40, and 55. Ages below 18, for example, test with 10 and 15. Ages above 65, for example, test with 70 and 80. Section 9. Boundary value analysis. Testing the edges. Using the same age input field example, boundary value analysis focuses on the edges of the valid and invalid partitions. Test with 18 and 65. Test with 17 and 66. Section 10. The black box testing process, a step-by-step guide. In this section, we will delve into the detailed steps involved in black box testing, a crucial method in software quality assurance. The black box testing process typically involves the following steps, each designed to ensure the software meets its requirements and functions correctly. Step 1. Understand the software's requirements and specifications. This involves thoroughly reviewing all documentation to grasp what the software is supposed to do. Step 2. Create test cases based on the requirements, using techniques like equivalence partitioning and boundary value analysis. These test cases should cover all possible scenarios to ensure comprehensive testing. Step 3. Execute the test cases, providing input data and observing the output. This step is crucial to verify that the software behaves as expected under various conditions. Step 4. Document and report any defects or deviations from the expected behavior. Accurate documentation helps in tracking and fixing issues efficiently. Step 5. After fixing defects, retest to ensure the fix is effective. Additionally, perform regression testing to ensure that changes haven't introduced new issues. This step is vital to maintain the integrity of the software after modifications. Section 11. Advantages and disadvantages. Weighing the pros and cons. Black box testing offers several advantages. Focuses on the user experience and ensures the software meets user needs. This type of testing simulates real-world usage, making sure that the end product is user-friendly and intuitive. Allows for testing from an independent perspective, free from developer bias. Independent testers can provide an objective view, which is crucial for identifying issues that developers might overlook. Helps identify defects early in the development cycle, reducing costs and time for fixing them. Early detection of bugs can save significant resources and prevent potential issues from escalating. However, there are also some disadvantages. Without knowledge of the internal code, it's impossible to test every possible scenario. This limitation can lead to gaps in testing coverage, leaving some areas untested. Testers may miss testing certain areas if they are not aware of their existence based on the specifications. This can result in undetected bugs that might affect the software's performance. When a defect is found, it might be challenging to pinpoint the exact cause without understanding the internal workings. This can make debugging more time-consuming and complex. Despite these drawbacks, black box testing remains a crucial aspect of software testing. It provides a valuable perspective that complements other testing methods. It helps ensure that the software is functional, reliable, and meets user expectations. By focusing on the end-user experience, black box testing plays a vital role in delivering high-quality software products. In conclusion, while black box testing has its limitations, its benefits in ensuring user satisfaction and identifying critical issues early on make it an indispensable part of the software development process. By balancing the pros and cons, teams can effectively integrate black box testing into their overall testing strategy, ensuring a robust and user-friendly final product.